Good morning, students. Can you all see my screen?
Yes, miss.
Okay, so I hope that you all have downloaded R and you all have installed that. And after installation, you will see that blue color icon, which I showed you in last week lecture. So when you double click on that, you will see the console window like this. So this is the first window that you will see when you open R. So we call this as the console of R. So you can see here your cursor, you can see the red color cursor. And since this is the first time that we are explaining R, so I will give you a brief introduction how to work with R. So why we are using R, it's very easy to work and it's free to download and you can easily install that into any platform. So when it comes to R, when you want to use a particular object in R, so if you want to assign a value in R, what you have to do is, for an example, let's say you want to use an object called X, where X is equal to 2. So what you can do here is you can just type X equal to 2 like this, right? And if you want to check whether you have correctly assigned the value for X, you can just type X and enter, then you will see X is equal to 2. So if all of your commands are smoothly running, your cursor will go to the next line. But if there is something wrong with your command, there will be an error message in R. So when it comes to this assigning part, you can use the object name and equal sign and the value of the object, or else you can use, let's say, y is equal to 3, object name and an arrow like this, and the value. So if I just type y here, you will see y is equal to 3. And then there are some special symbols that you can't use in R when you are naming. Especially you can't use plus sign, minus sign, and also hash mark. These marks you can't use when you are sorry, here you can't use plus mark and let's say minus mark. All these marks you can't use when you are naming the objects, right? So you can see when I just when I write these marks, I have started writing using a hash mark, because when it comes to R, if you want to include a comment, you have to use hash mark. Then you can write any comment starting from the hash mark. And at the same time, if you are using dot and underscore, you can start the object names using dots and underscore. For an example, let's say dot x is equal to 3. So it's possible. If you just call dot x, you will see there is a value assigned for that. So it's possible. And if you just write underscore y is equal to 5, here when it comes to underscore, underscore you can't use at the beginning of a name of an object. But if you just write it like this, y and x underscore y equal to 3, then it's possible. So you can see when you just write or when you enter a incorrect command, you will get an error message, right? So you can see when you write your command in a correct way, your command is running smooth. So you can use dot and underscore, and you can even start with the dot. But if you're using underscore, you have to include that in the middle of your name of the object. And also if you want to use numbers, then you cannot start with the number for a name of object, but it's same as the underscore, you can use it in the middle or wherever you want in the name of the object, but you cannot start with a number. For an example, if you let's say x1 equal to -1. So this is possible, but if you write 1 x, here you will get an error message. So you cannot start with a number, but you can include a number in the middle of the name. And at the same time, R is case sensitive. So if you use, when you're using capital simple letters, R will take those objects' names as two names. For an example, now if I write simple x, now here we have assigned simple x as 2. And if I just call capital X, here capital X is equal to 5. So it's some other object. We have two different objects. For an example, if you just write, let's say there is a variable called temperature, and I'm going to assign 10 for temperature like this. And I'm going to write the same variable name, but for P, I'm going to use a capital letter, and then I'm going to assign it as 20. So if you just call temperature here, if all the letters are simple, you can see the value is equal to 10. And if you call this one, if only one letter is, or if only P is capital, you can see temperature has been assigned to 20. So it's case sensitive. When you are using simple case and capital uppercase letters, R will recognize them as two different object names. So you have to remember that. So what you can do here is, today when I'm doing this session, you can do it with R. So that will be easy for you. So if you come across with any question, we can discuss, right? So now when you assign the object names like this, when you're working with R, if you want to see what are the variables that I have assigned so far, if you want to get the list of variables that you are working with, there is a function in R called lists. So in lists function, we can just check what are the variables that we are working with. For an example, the list, if you want to use the list function, there are so many inbuilt functions in R that we can use. So in this case, if you want to use the list function, you have to type simple L and simple S, and then you have to put 2 brackets and enter. So then you will see here, these are the values. These are the variables that I have assigned so far in R. So we are using all these variables in order to, we have assigned the values to all these variables. So let's say we have so many variables and we are just, one is having a question, you can ask. Mayur, what's your question, Puta? You have any question? Okay, right. So in this case, if you want to check what are the variables that you have assigned, which are starting from, let's say, simple X, in that case, we can use the same function list, that is LS. But inside this function, what you can do is we can write pattern equal simple x. And then when you enter, you will see all the variables which are starting from simple x. Right? So when you take this function ls or this list function, there are so many arguments that you can pass inside this function. So I will tell you how to, like, you can just observe when it comes to R, all the R codes are available. When you Google it, you can find all the R codes. So it's very easy to use. But if you're really interested, you can just go through the help in R, and then you will see what are the arguments that you can pass into this function. So in this case, we were interested about the names of the variables which are starting from x. So what you can do is you can take the function list OLS, and you can use pattern equal to simple x, and then you will see the names of the objects, so names of the variables that we have used and which are starting from simple x. So in this case, let's say we want to remove a variable. Let's say I want to remove the variable x_y from my variable list. So in that case, I can use this function rm. It is the function to remove objects. So in this case, if you want to remove any objects, you can use this function, and inside the brackets, you have to give what is the variable that you want to remove. So let's say I want to, inside the brackets, you have to give, I want to remove variable x. So now let's check whether variable x has been removed. So you can just call function ls and enter. So you can see now variable simple x has been removed from the list. We can't see it here. So it has been removed. So let's say I want to remove two variables at the same time. So at the same time, in that case, let's say I'm going to use the remove function, and I'm going to remove the variable age and temperature. And then now again, if I call the list function, you will see these two variables, age and temperature, those two variables, they have been removed from the list. So if you want to remove any variable that you have used so far, you can just use this remove function. And now, since we are talking about modeling, so when we have, actually we started with the simple linear regression. So when it comes to simple linear regression, the most important thing is the first step is to observe the scatter plot. So when you have two variables, we want to get the scatter plot to check the behavior of the two variables before fitting the model. So in that case, if we are interested about fitting a scatter plot for a given data set, that also can be done using R. So let's say we have two data sets. I'll take the first data set, let's say Z1, or let's say capital X. So I'm going to take capital X data set. So here, if I have so many values that I want to assign for a particular variable, we have to use it as a vector. So if you want to use or assign a vector for an object in R, so you can use the name of the object, arrow mark, or you can use the equal sign, and simple C, within brackets, you have to give the values of the objects. So I'm going to just give some values. Let's say 1, 2, 3, 4, 5, and 6. You can just use commas and give the values. And now I'll just type capital X and enter to check whether the values have been assigned correctly to my variable. So you can see all the values have been assigned to capital X. And I'm going to take another variable, capital Y. And then I'm going to assign these values to capital Y, 6, 8, say 3, 5, 7, and 1. So we'll just check, and we can see capital X and capital Y, they have been assigned correctly. So in this case, if I want to take the scatter plot between X and Y, so I have to write plot, and then I have to write, first I have to write the X variable, and then I have to give the Y variable, and then you will see the scatter plot. So I don't know whether you can see it right now because it's coming, the output is coming in a separate window. So if you do that by yourself, you will see the scatter plot. And when it comes to the scatter plot, you will see there is no title for the scatter plot. So if you just type title, and then within brackets, you can give the name of the, or you can give the title of the scatter plot. I'll just write my first scatter plot. In inverted commas, you can write, and then when I enter, you will see here when it comes to R, if you go to this Windows, and then you will see R graphics. If you click that, you will see the plot. So there you will see the title and the scatter plot. And if you want to go back to the console, here you have to go to Windows and click on R console. Then you can just type all your commands there. So when you are working with R, if you want to save all these names of the variables that you are working with, what you have to do is when you are going to close R, for an example, now if I just click on this, when you're going to close R, it says, it's asking us whether we want to save workspace image. So if you just click it as yes, then all the names of these variables with their values will be saved, right? And in this case, they are saved, all these values, they're saving into the current working directory. So if you want to check what is the current working directory of R, you have to use this function. Let's say get wd. See, now if you just go and check, now in my case, if I go to my C drive, users, As and documents, there is a R file that has been created. If I use, when I save my work, they will save all those work as a R file, .r file in this particular folder. But let's say I want to save, if you want to just without closing this whole program, if you just want to save, there's a function called save.image. You just write save.image. Then all the work, all the variables that you have done so far will be saved as an R file to this current working directory. And let's say you want to save all these workings to a particular destination. You want to give a specific file location to save all these details. In that case, now, for an example, let's say now I have created a folder in desktop as R files. So I'm going to take the link of that. And then what I can do is I can use the same save.image function. And what I can do is within inverted commas, I can give the location like this. And here you can see all of these, we have to replace this backslash with double backslashes, and then And then after the location, again, 2 backslashes, and then you have to say, we are going to save this as a .r data file. So you have to give as .r data, an inverted comma, and close the bracket. And now you will see, if you just go to this folder, you will see at the end, I will show you, you will see that all of your workings has been saved as a .r file in this specific location. So if we want to change the working directory, right now all the workings are saving, they are as a default, R will save all your workings in this current directory, and if, when you give this save.image, R will save only this file, only the objects of this file into this particular location. But if you want to save all the workings to this location, you can change your directory. So if you want to change your directory, again, you can use this function, which is known as setwd. So what you can do is you can use the function setwd, and inside the brackets within inverted commas, you can give the location of location, or the specific location that you want to change the directory. And then here what you have to do is here I'm going to replace these backslashes like this, and then when you press enter, now your directory has been changed to this specific location. If you want to double check that, you can call getwd function and check. Now see, now our directory is this. So all the workings are saving into the folder which is in the desktop, which is known as R file. So if you can change your current directory using this. So now let's say after working with R today, you close your file, and then you are going to start working again tomorrow. So in that case, when you want to open this, when you want to use the same objects to continue your workings, you can just use this .r file which we saved. So in order to use that .r file, you have to load your .r file. And also, if you want to use the same commands, that is, if you want to use this plot command, title command, if you want to use this X vector, Y vector, if you want to use the same commands, the commands also we can save into a separate file in R. If you want to save the commands, you can write this function, which is known as save history. Right, and inside the brackets, you have to give the name of the file. Let's say file is equal to, I will give my file, let's say my file 1. So now all the commands up to here will be saved into this my file 1. So when you close R, and in the other day when you want to work with the same commands, you can load these commands to R. So what you can do is, when you load these commands, you can use load history function. And then within brackets, you can again write down the name of the file that you want to load. So the name that we gave is my file 1. So you can write my file 1 as the name. And then now you will get all the commands to work again in the same workspace. So you can continue your work. Right? Do you have questions up to that point? And students, please send your index number. Please inbox your index number to me to get the attendance. Okay, and If that is okay with y'all, now you have a basic understanding how to open R and how to assign objects, how to get a scatter plot, and how to save your work into a specific location or into the same working directory. And then we are interested about, since we are working with modeling, working with statistical modeling, we are interested about data. So when it comes to R, there are so many inbuilt data sets in R. So if you just want to check what are the inbuilt data sets in R, you can just write data and 2 brackets and enter. Then you will see list of names here. So all these names are, these are the names that these are the data sets that you can see in R. So we can use all these data sets in order to work. I don't know whether it's, can you see the names of the data sets now?
Yes, ma'am.
Okay, so all these data sets we can use when we are using R. Now, for an example, if you just, let's say, let's say this air passengers data, right? So if you just want to check this air, if you want to check about this air passengers data, what you can do is, if you want to know more information about air passengers data, if you just write air passengers, sorry. If you just write help and within brackets as air passengers, then you will see in a separate window, you will see the you will see a whole description about this data set. I will show you that. So just like this, in a separate window, they will give you the whole description about the data set, right? The format and what are the variables that they have entered. So all those information are here. So if you are going to work with one of these variables, what you can do is you can just select the variable that you are going to work, and you can use the help function. And when you give the name of the data set, inside the brackets, you will see the description of your data set. So it's easy for you to work with that. And then so when it comes to R, not only the data sets, there are so many different formats of data that we can use. Now, when we were like fitting the scatter plot, you saw that we assign the values for capital X and capital Y as a series of values. So in that case, we can call them as vectors. So we have, when it comes to vectors in R, when you want to assign a series of values to a particular variable, it can be numeric or it can be a character variable. Now, for an example, if you take A, let's say I'm going to assign series of values to A. So in this case, let's say 1, 2, 5, 3, 6, -2, 4. I'm going to assign all these values for simple A. So in this case, R identifies A as a vector. And since all the values that we have assigned to R are numbers, R is identifying A as a numeric vector. But let's say we have another vector. which is a character vector. In that case, let's say my first value that I want to enter is 1. So when you are dealing with the character vector, you have to, when you write down all the values within brackets, you have to write down within inverted commas. So let's say the next value is 2, and then the next value is 3. Likewise, we can use. So in this case, if I call vector B, you can see I have only characters. So in that case, it's a character vector. And let's say I have another vector C. So in that case, I'm going to enter values as like this. So you can see in this particular vector, you have true, false, right? So in this case, it's a logical vector. So whatever the format that you want to use, we can use in R. So in simple linear regression, in most of the cases, we are dealing with numeric vectors. But when we are going for other designs, we'll be dealing with characters as well. So this format will be useful to you. Now, if you take this one, my vector A, if you want to, let's say, if we want to extract not all the elements of this vector, we want to extract some specific elements of this vector. So let's say I want to take only the second element, and let's say the second and fourth element of vector A. So what I can do is I can write the name of the vector, and then I can use square brackets. And inside the square brackets, as a vector, I can pass the location of the values that I want to extract. Now, I told you I want to extract the second value and the fourth value. So as a vector, I'm going to pass this inside the square brackets. And see, you can see the second value is number 2 and the fourth value is number 3. So R will extract second and fourth elements of the vector like this. And also when it comes to R, we can use matrices as well. In R, we can use matrices to store our data. So when it comes to matrices, now let's start with the very general or simple format. Let's say we have a matrix called simple Y. And so if you want to assign values for this matrix, so we have to use the function matrix, Y equal or Y arrow matrix function. And then within brackets, the first thing that you have to do is you have to give the values which are stored in this matrix. Let's say I have numbers from 1 to 20. So you can give that numbers as this, numbers from 1 to 20. When you use a colon, it says all the numbers from 1 to 20 will take into account. And then what you have to do is you have to mention how many rows are there in this matrix. Let's say I have 5 rows, so that can be assigned by the variable n row. And then how many columns your matrix has, that you can write as n column equal to 4. Right? Now, when I enter this and when I call Y, you will see this output. You can see you have 5 rows and you have 4 columns because we have assigned 5 rows and 4 columns. And in this case, if you look at the values here, you can see 1, 2, 3, 4, 5. The first 5 values they have assigned as the first column. The next 5 values as the second column, likewise. So what happens in R when you give a particular data set and when you ask R to when you ask R to build a matrix using that data set, by default, what R is doing is first R is filling the columns. But if you want to do this in the other way around, that is, if you want to place this data by rows, what you can do is you can use the same command, and then here you can use by row equal true. If you use this one, and now if I call my matrix, you will see now the R is placing the data set by rows. You can see in the first row, you have the first 4 values. And in the second row, you have the next 4 values. So likewise, if you want to fill your data set or your matrix by rows, you have to indicate that as by row true. Otherwise, by default, R will first fill the columns. Now, for an example, let's say we have another set of data to be included into a matrix. So in this case, all the set of data that I want to include in my matrix, I'm going to take it as a separate vector. So let's say for the cells of the matrix, we are going to take these values as a separate vector. So I'm going to take, let's say, some of the values, 1, 26, 24, and let's say 68. So if I just call the variable cells, you can see it's a vector, numeric vector with 4 values. And now what I'm going to do is I'm going to put all these 4 values into a matrix. But in my matrix, now if you look at this previous output, if you look at the columns and if you look at the rows, by default, R is just giving the names of the columns and rows as 1, 2, 3, 4. So in this case, if I want to give a specific name to rows and columns, that also can be done in R. So what you have to do is we have to first assign the names of the rows and columns. So I'm going to assign the names of the rows. So I'll take it as a character vector. The row names, I'll take it as R names. And now I'm going to give the row names to this. So that is R1, R2, and then I'm going to give the column names. I'll take that as C names. So I will give it as C1 and the next name as C2. Now I have stored the names, the column names and the row names of my matrix. So I'm going to form my matrix. I'm going to give the name as my matrix. And then I'm going to use the matrix function. And within brackets, the first thing I have to give the values that I'm going to put into my matrix. So that we have assigned as this cell, assigned all the values into this vector, which is known as cells. So I'm going to include cells here first. And then I have 4 values. So I'm going to put 2 rows and 2 columns. So I'm going to write number of rows equal to 2 and number of columns that is equal to 2 again. And then what I have to do is I want to fill the values by rows. So I'm going to write by row function equal true, right? And then I want to include these column names and the row names that I have already created. So what I have to do is, in this case, I'm going to use the this function which is known as dim names, that is the names of the dimensions, right? Dim names, and then dim names equal, you have to use the function list, and within brackets we have to give the names of the 2 vectors that we have stored the names of the names of our rows and columns. So that is, we have R names, we have R names, and we have C names. And then when you just call my matrix, and enter, you will see you have your matrix with all the row names and all the column names. So in this case, when you want to, now you know how to store a matrix. Just as in a vector, if you want to extract a particular element in a matrix, then again, you can use the name of the matrix. Now, in this case, I'm going to use the name as my matrix. Now, if you then, when you are extracting the elements of the matrix, you have to use the squared values. So in this case, let's say I'm going to use 2, comma, and enter. So what will happen? That is, if you use this command, this will give you as the output the values of the second row, all the values of the second row. So if you just use the same command like this, if you want to extract the second column, then you want to extract all the rows. So it within square brackets, the first you have to keep a space and then comma or second column. So all the rows in the second column, you have to write like this. Then you will get 26 and 68. That is the second column elements. And let's say we want to extract the value 68. So that is the second row and second column. In that case, we can just give the location. We want to extract the element which is in the second row and the second column. And then when you enter, you will see, you will get the value as 68. So likewise, you can just enter or just extract any value from the matrix that you want to do in your calculations. So if you can remember when we were discussing about the matrix form in simple linear regression and multiple linear regression, you wanted to do so many calculations. So now you know how to enter the values as a matrix. So as for homework, you can just check how to do the calculations in matrices in R. So when it comes to the variables, like if you say x equal to 2 and y equal to, let's say, -3, you can do any calculation using x and y in R. Let's say you want to add x and y, and you want to subtract x and y, and if you want to multiply, and if you want to divide, any of these operations you can do in R, and it's the same when it comes to matrices as well. But as for homework, you can just check how to write those commands when it comes to matrices, right? Okay, and now you have any questions up to that point? Also, please send your index numbers. Please inbox me your index number, then I can mark your attendance. If you have any question, you can ask. So if you were unable to do with me, what you can do is, after I will be uploading the recording within the day, so you can just go through the recording and just do all these steps by yourself, right? Because you have to be very comfortable with R to do the analysis. Then it's very easy for you. Okay, so if you have no questions up to that point, I'm going to talk about data frames in R. So we discuss about vectors at the initial stage. We discuss about objects, the variables, when you have only one value, how to assign. When x is equal to 2, how to assign it into R. And then x is having so many variables, right? For an example, if x is age, and if you have collected age values of 20 students, how to assign those 20 values into age. So there, what you have to do is you have to take all those 20 values as a vector and then assign that to your variable age. And then we discuss about matrices. And there's another one in R, which is known as data frames. Data frame means when you have different vectors. Let's say when you're fitting a model, you have collected information about the gender of the students, their age, and maybe the number of hours that they are studying and their final GPA. So you want to put all this information into a one file. So when it comes to GPA, the number of hours and age, all these are numeric values. But when it comes to gender, that is again a character variable. So if you have all these, we want to put all these different formats of variables into one sheet, then you can use a data frame in R. For an example, let's say we have I have a vector called D, and this is the numeric vector. I just put the values as 1, 2, 3, and 4. And then let's say I have another vector called E, where I have characters there. So there I have, let's say, red, and let's say I have white, and third student's, let's say, favorite color is red again. And the next student, let's say that I have extracted these from some of the students. So let's say D is the ID of the student, and let's say E is their favorite color. And let's say when it comes to the fourth students, I was unable to record that student's color, the favorite color. So in that case, that is a missing value. So if you have a missing value in data in your data set, we can also include missing values in R using NA, right? So I have a missing value in this vector, and then I'm going to take the next one as well. So let's say this is a logical vector. So I have, let's say, true, and false. So I want to put all these vectors into one data file. So in that case, what I can do is I can first give a name to my data set. I'll take it as my data, and you can use the equal sign or this arrow. And then what is the function that we are going to do is we are going to convert all these information into a data frame. So data.frame is the function that you have to use, and inside brackets you have to give all the vectors that you want to include in this file. So I want to include D, E, and F. Right, so if I just call my data and see, you can see you have as the first column, you have D, as the second column, you have E, and as the last column, you have F. So if I want to give what is the first column, it's the IDs of the students. The second column is the color. The third column is whether the student has passed the exam or not. So if I want to rename all these columns, that also can be done in R. So what you have to do is you have to use the function names, and within brackets, you have to give the data set to what we are going to give names. So our data set is my data. And then you can use the equal sign or this arrow. And as a vector, character vector, you have to give the names. So the first column's name, I'm going to give it as ID. And the second column name, I'm going to give as color. And then the third column name, I'm going to give as this, past. Okay, so then If I call my data again, you will see now they have nicely put all these column names to my data set. So this one we call as a data frame. So you can include all your data, the data that you have collected by doing a survey as a data frame like this. So when it comes to a data frame, if you want to extract specific values, that also can be done in data frame. So what you have to do is first you have to write down the name of your data set, and within square brackets you have to write which column that you want to extract, whether it's the first column, the second column, or the third column. Let's say if I just put 2 here, it will extract you the second column. And if you just write the name here, for an example, if you just write here, let's say ID, so then your data set R will extract the column ID for you. So likewise, you can extract your values in your data frame. Or else if you use, again, if you use the name of your data frame, my data, and if you use the dollar mark and the name of the variable, I'll use the first variable ID, again, that will extract you the first column or the variable ID. So when you're working with R, you can just use this dollar mark with the name of your data frame to extract the values of that variable. Or else what you can do is there's a function called attach. And if you use this attach function, and inside the brackets, if you just indicate the name of your data set, then if you just write down, if you just call the names of the variables, R will quickly identify what are the values. In that case, you don't have to use the dollar mark. But if you are not attaching your data set into R, then you have to use the dollar mark in order to access the variables, the values of your variables. So that is about data set. Data frame. So when we are working, when we are fitting models also, we can easily store our data as a data frame. You have any questions up to that point? Okay, so if you have no questions, now in this case, you can see when it comes to R, I just explained you, we can indicate the missing values using NA. When you have missing values, you can use them as NA. So if you just, now if you just take this one, my second, that is, if you just check this vector, that is my vector E, which I have a missing value here. So if you want to really check whether there is a missing value in your data set, what you can do is you can use this function is.na, and within brackets you can give the name of your vector. So in this case, when you pass the name of your vector to this function will check whether each and every value is a missing value or not. So you can see only the 4th value is the missing value in our data set. So in that case, it will show that the 4th value as a true value because there is a missing value. So in order to check whether there is a missing value, you can just check. You can just use this is.na function. Now for an example, let's say we have another data set, C, a numeric vector where you have, let's say 1, 2, 3, 4, and the last one is a missing value. In this case, if you just call is.na function and y, you will see R will indicate the last value is a missing value. So when you have a missing value, If you want to calculate the mean, median, all these things, there are inbuilt functions in R. So if you just calculate the mean value, you want to calculate the mean value of this vector y, you will see when you use this inbuilt function mean, it will show you as a missing value, right? That's because if you have missing values, you cannot use the inbuilt functions in R because it returns as a missing value. So you can't calculate, you can't just calculate these operations by the inbuilt functions. So what you can do is, if you can find that there are missing values in your given vector, what you can do is, if you are really interested in calculating mean, you can just use the inbuilt function mean. You want to calculate the mean of y, and then what you have to do is you can remove the missing values from the vector. So to do that, we are going to use this function na dot remove, rm equal true. So that is, we are asking to remove the missing values and then to calculate the mean. So then it will take 1, 2, 3, and 4 and we'll calculate the mean value. Right? So in this case, you can calculate the mean value like this. So if you and let's say now we have when it comes to our data frame, my data, so here also we have a missing value. No, if you look at the 4th row in the second column, we have a missing value. So if you want to just omit this missing value and we want to obtain a new data frame, what you can do is, let's say my data 2 is equal to, we can use this function that is na dot omit, and we can use the name of our data frame. And then if I just call my data 2, you will see that will omit the missing values and you can have the rest of the data set without missing value, without missing values in rows. So you can use that also when you are working with R, when you are working with data frames. Okay, so now what we are going to do is how to import an Excel file in R. So when we are building our models, that will be really useful for us. We can store all our information in an Excel file, and then we can just import that Excel file into R. So I'll show you how to import an Excel file. So before importing the Excel file, what you have to do is you have to let me share with you. Yeah, so let's say when it comes to your Excel file, can you see my screen?
Not yet, madam.
Can you see the Excel file? No, not yet.
Not yet, madam.
Okay. Now you can see, right?
Yes, madam.
Okay. So in this case, now what I have done here is, now if we are going to fit a simple linear regression between X and Y, So I have placed my X variable and Y variable here into a Excel. So Excel sheet. So what you can do is when you are saving this Excel sheet, you have to go to, when you go to File, say Save As. And you have to save this as a CSV file. So you can give whatever the name that you want. I'll give as test1. So you have to save this as CSV, comma, delimited file. That is what you have to select. And then you have to save the file like this. And do OK and yes. And now you can import this file to R. So I'll show you how to import. So when you're importing a file, in that case, first you have to give a name to your file. So I will give the name, let's say, my data set as the name. And then you have to use arrow. And then you have to use this function read.table. And then inside the brackets, you have to give file dot choose, again brackets, that is we are asking to choose the file, and header equal true, that is we are asking R to include the column names as the headers, and then you have to say sep equal comma, that is we want the two columns separately, right? And then when you run this command, you will see R is asking you to select your data set. So wherever you save your data set, you can just browse it. And now in my case, that is the test1. I can select the data set from the folder that you save, the CSV file, and open. And now the R has stored my Excel file as my data set. So you can check it. So you can just call my data set, the name of our file, and then you will see the R has stored all the values of X variable and the values of Y variable nicely. So we can work with that. So in R, as we discussed, there are different formats of data, vectors, matrices, data frames, and so on. So when you want to check what format is your current variable, or if you are given with a variable which you have no idea about the format, that also we can check in R using this function, that is str, that is we have to check the structure of our variable. In this case, if you just write my data set and run, you will see it says the variable that we have created is a data frame. So when we import an Excel file to R will store it as a data frame. So it will be very easy for us to work, especially when we are modeling. So you can see, so here it says in this data frame, there are 10 observations and 2 variables, and they have given the variables separately. So in this case, we can use these values in order to fit the models. So up to that point, do you have any questions? Okay, so if you have no questions, I think now we are ready to do modeling. So you have a basic understanding how to import data, how to store data, how to assign values, and how to save all your work in R. So I'm going to close this and then I'm going to save all these workings. And now I will show you I will show you the files that has been stored now. Now this is my folder which I have created in the desktop, which is known as R file. So if you can just see, you can here there is a file called test1. That is the CSV file that we saved here. And if you just check here, we have another file called myfile1. So that is the command file. And here we have .r file also. So in this, by loading these files, you can access the same commands and the same variables that you used in your previous session and continue to work with them when you're working next time with our software. So I think if you have any questions up to that point, you can raise. If you don't have questions, what you can do is you can just practice. I will be uploading a tutorial up to the points that we discussed so far, and you have to do that tutorial and submit that before Friday. And tomorrow we'll be discussing an assignment, the remaining parts of assignment 3. So on Friday, before Friday's lecture, you can submit the tutorial which I'll be submitting. And then you can practice all these things. So then you'll be familiar with R. Then we can start fitting regression models from our next lecture onwards. So do you understand and you have any questions, students? Crystal clear? Okay, then we will stop from this point. We will again meet tomorrow. Thank you and have a nice day.
Thank you.
Thank you, madam.
Thank you.